Students, let us understand what is acceptance angle. The maximum angle at which light can enter the core of an optical fiber relative to the axis of fiber such that it gets transmitted through the optical fiber. So this is possible when incident angle is greater than the critical angle of the core cladding interface. As you can see in the diagram, this is the core layer, this is the cladding layer. Core is generally the inner layer of the optical fiber and cladding is the outer layer, and both are soft glass fiber materials and both are transparent. Okay, so acceptance angle is the maximum angle at which light can enter the core of an optical fiber relative to the axis. So this is the axis, of the optical fiber, and this theta max you can see is the acceptance angle which can enter. Okay, so now in this video we will derive that expression for that acceptance angle. Now for the derivation, suppose n1 is the refractive index of the core and n2 is the refractive index of the cladding, and generally the refractive index of the core is greater than the refractive index of the cladding. That is done because we have to carry out the total interreflection. Okay, that is the important condition. Okay, so now we all know that in case of your total interreflection, when your angle of incidence is equal to the critical angle, then your angle of refraction becomes 90 degree. Okay, so if I will apply Snell's law, that is sin I by sin r is equal to 1 and 2, we write generally 1 and 2 means this is refractive index of medium 2 with respect to medium 1. So here in place of writing 1 and 2, I have written n2 by n1 because there is a formula for refractive index, that is 1 and 2 can be written as the ratio between the absolute refractive index of medium 2 to the absolute refractive index of medium 1. Okay, this formula is used here. Okay, because we are using core and cladding interface, that's why. Now you can see this theta r is 90 degree. So by making this 1, we will get sin theta c is equal to n2 by n1, that is your equation 1. Okay, so now you can see here in this diagram, this is theta r and this is theta c, and you can see that in the interface there is a normal drawn here. So as it is a right angle triangle, this angle is 90 degree. So this theta r and theta c, the sum of these two will becomes also 90 degree. So that's why we can write theta c is equal to 90 minus theta r, which I have put here. See, sin theta in place of sin theta c, I have written sin theta minus 90 minus theta r. Okay, so this can be written as cos theta r, that is equal to n2 by n1. So this cos theta r can be written in this way also, under root of 1 minus sin square theta r is equal to n2 by n1, because we know by trigonometry sin square theta plus cos square theta is equal to 1. This equation 2 is inside the optical fiber. Okay, now if we will go outside and if we will apply the Snell's law for the medium between air and the optical fiber, because generally light is sent from the air medium into the optical fiber, and here n0 is the refractive index of the air medium. Then if I will apply the Snell's law here, it will be sin theta I by sin theta r is equal to n1 by n0, because here medium 2 is n1 and medium 1 is n0. Okay, so as we know, in order to get the acceptance angle, we have to make this theta max. Instead of writing theta I, we will write theta max. So sin theta max by sin r is equal to n1 by n0. Here I have taken this one, okay, for acceptance angle. So now sin theta r will be equal to n0 by n1 sin theta max. This is equation 3. Now we will take this equation 3 and we will substitute here in place of sin square theta r. You can see we have got the value of sin theta r. So now putting this value and now squaring both sides, now you can see after taking the LCM, this will come n1 square minus n2 square sin square theta max, and this after taking LCM, this n1 square and n1 square will be cancelled from both the terms. Now we will have sin square theta max is equal to n1 square minus n2 square by n0 square, or we can also write sin theta max is equal to under root of n1 square minus n2 square by n0. Now finally, as you know that for air medium, our refractive index for air is always considered as 1. So if we will put the value 1 here, we will only get sin theta max is equal to under root of n1 square minus n2 square. Now to obtain the value of the theta max, that is the acceptance angle, we have to take the sine inverse of this term. So this is the formula for your acceptance angle. Okay, so this can, if you take LCM both sides, this n1 square value cancelled, and you can get the following expression. Okay.